Hello, my name is Victor Lopez, and today I want to show you this open source Python module that I've published that implements a simple spaced repetition algorithm or scheduler. This is the one we use at Python.cards, the site I'm building for learning Python using spaced repetition. So the funny thing is that earlier today, I recorded a video, and it's here in my channel, and in which I was working for about 1 hour on the scheduler code that I had implemented some months ago. After recording the video and being quite happy with the result, I started thinking, and then I came back to the code, and I did a huge refactor that I didn't record, but that I'm going to show you now. So what happened? We could go to GitHub and see actually the code that I published in the previous video. It is this one here. It has a few problems. First, I reduced the code to under 100 lines, which was the goal that I said that I had in this previous video. But if you watch that video, you will see me rambling quite a bit around the algorithm and not being able to perfectly explain how the algorithm works, which is something that I don't like. And second, well, we have I had some ideas, let's say, on how to improve or how to make this code more concise. So when you're coding this, I'm going to show the code that I came up with in the end. In the end, it is less than 40 lines. And this code has some pros and cons that I like to go through because I think it's an interesting exercise. So as you can see, one thing I did in the previous video is extract all of these magic values that are usually called. This initial is, min is, again is delta. So it's interesting to, instead of having magic numbers, to have names for these variables. This is standard good clean code software design tips, right? Same for the statuses. I had these constants for the strings. But now let me show you the code that I ended up with, which does the opposite thing. Okay, and let me explain you why. This is the code. This code is shorter, clearly, and it doesn't follow the same conventions. For example, here I had all of these constants. Here I removed all of the constants. Here I had even the learning and so on. It's copied many times. So you would say, why do you have this string here so many times? This is bad practice. It serves a purpose because this module, if you remember, is called simple spaced repetition. That means I want to make it as simple as possible. By having it so concise like this, and now we're going to go through the algorithm actually, it's very easy to understand, or it's very easy to understand the scope of what you need to understand. So the problem with having these magic values like learning instead of a constant is that if you introduce a typo, if many people touch this code and so on, you could introduce a typo and then the code doesn't work as expected. But when you have so few strings, or you can see them all in one screen, in one viewport, it is not really necessary to have these constants. And in fact, all of these parameters, so for example, here I had this initial is 2.5. Where is this 2.5 now? This 2.5 is here. So this is the initial is, so this is actually the initial value, the default value that you get when you create an object of this class. Similar for this, we have this min is 1.3, and here we do this max is 1.3, which actually means that the is will never go below 1.3. So you have to the trade-off that I took here is that I kind of have self-documenting code. At least the code is as simple as possible, in my opinion, so you can actually learn what it does through the code and not so much through good names or documentation. The reason I did this is that I don't think that anyone will be changing these values unless they really know what they do. And that is very similar to just coming into the implementation and changing the value here. Also, the most important thing is that this code makes the implementation very obvious. So the algorithm can come to life. We can see it with our own eyes, what the actual scheduler algorithm of the spaced repetition does. when we had all of these functions, helper functions, and so on, it was much more difficult to really grasp what the algorithm was doing. So, very quick, what is this algorithm doing? Let's first use it. So we see, from simple spread repetition, we import card and we create a card. This card has these attributes: status learning, step 0, interval none, is 2.5, which is what this represent function outputs. And it has a single function, it's options. So there's not much more that we can do with this card, right? What are the options? And here are the options. And the options just have, it's a list of pairs, of tuples of only 2 values. Again, hard, good, easy, and a new card. This new card is the result of applying again or hard, pressing again or hard into the card that we are working on. And this card has this interval, and the interval is actually the time where this will be due. So this is 1 minute, 6 minutes, 10 minutes, 4 days. If we take the second option, which is good, and we take this card, and now this is not the way you will manage this usually, but if we take this new card, now this card has, it is still learning. It is on step 1, which is different than step 0, which is what this one had. It has interval 10 minutes and it has is 2.5. Now, if we take the options, these are different. Now, if you press good, it is 1 day. If you press easy, it is 4 days. Well, that was the same, actually. Sorry, but now let's take the easy path, right? So again, excuse me, if you take the easy path, which is the last one, and you take the card, now we have this card. It's reviewing. This is a different card. If we take the options, if you press again, it will be relearning. If you press hard, it is reviewing, and the interval is 10 days, 15 days, 4 days. The ease is decreased. If it is hard, it is the same. If it is good, it is increased. If it is easy. So this is how you use it. You could say, for option, or you could say for answer new card, print answer card or new card. This is another way of printing the option. So you have a for loop. You have a for loop and you print all of these, and then you could imagine how you can integrate this into an actual application, right? You could have all the answers that the user or you yourself press. So you could say, good, easy again, good, easy again. And you could apply these answers to a single card starting from the beginning, the learning status, and then get what the actual options for today are. So this is the simple module, the simple spaced repetition. Let's check the algorithm real quick. So first of all, the initial status is learning. It has interval none, is 2.5, step 0. The important fields here are status. A card can be learning, reviewing, or relearning. You are relearning when you kind of forget it. So if you have a reviewing card and you press again, then you are relearning. Then the interval is the actual time that you should review this card in, like in 2 days, in 3 days, in 5 days. And the ease is how easy or difficult it is for you to remember this card. It's kind of a factor. We will see how we use that. First of all, there's this maximum here. That means that if the ease goes below 1.3, it's kept at 1.3. So it doesn't go below 1.3. That's the mean ease that we want to allow. This is what Anki does in its classic version. So what are the options? If you are learning, initially you will be in step 0. If you press again, you are learning. You get a learning card again in 1 minute. If you press hard, then you go to step 1 and you review it again in 6 minutes. Note that it doesn't matter if you're in step 0 and step 1. If you're in step 1 and you press hard, you will stay on step 1. If you're in step 0, you will go to step 1. Then, if you press good, there's two options. You are either in step 0 or in step 1. If you're in step 0, then you go to step 1 and 10 minutes. If you were already in step 1, so you already pressed good before, you will get a reviewing card for tomorrow. And if you press easy in a learning card, so kind of the first time or the first day that you're reviewing this actually, you will actually get, if you press easy, you will get a reviewing card in 4 days. So this is kind of like a hard-coded, more or less, behavior for learning a card. It makes sure that you see it at least twice. If you press good and hard, you will see it twice. If you press hard, you will continue seeing it, and you will actually progress when you either press good twice or easy. Now for the reviewing. So reviewing is like the natural status. As long as you remember cards, you're in reviewing. If you press again, so you forget this card, it moves to relearning. It gets an interval in 10 minutes. You will see it again today. And you decrease the ease by 0.2. So it's kind of difficult for you, this card. If you press hard, this has a special value. Usually you multiply your interval by the ease, so 2.5 in the beginning. If you press hard, it is hard-coded to 1.2. So even if you increase the ease, how easy a card was for you, many times, if you press hard, it will only apply your current interval. So if this was 2 days, it will be 2 days, multiplied by 1.2. Then the ease is decreased. So if you set hard, the ease is decreased a little bit, 0.15. If you press good, everything continues the same. The ease is the same, and the interval is multiplied by the ease. And if you say easy, there is a bonus multiplier. So you multiply by the ease and by 1.5, and then you increase the ease. So this card is very easy for you. Finally, if you were relearning, so it's this card that you forgot, okay, let's review it. If you press again, you're relearning 1 minute from now. Interesting thing is that the ease is not modified. So if we kept this card as reviewing, even if we're relearning it, the ease would decrease very quickly if we pressed again many times. When you're relearning, you can press again as many times as you want, so you can review it 10 times in 1 day, that the ease will stay the same. You will review it in 1 minute or in 6 minutes if you are relearning. Once you say good, we start again reviewing with the basic interval, which is 1 day. And if it's easy, we are reviewing it with 4 days. This is the same thing, kind of, as when you were learning it. And that's it. That's the algorithm. You might want to read the frequently asked questions for Anki. So we have this, like here, the algorithm is explained a little bit more, but I think it's very useful to have a very so concise and short implementation. It doesn't matter, in my opinion, that these numbers are hard-coded. Like you wouldn't know what they are only by name. I think it's useful to see like how they are applied in the actual algorithm. And this program, this scheduler is not very customizable. So you cannot modify the parameters. You can modify it if you just copy the code and change it yourself. I think if you are interested in changing this kind of parameters, you wouldn't be scared probably of just getting into these options, this function, and just changing a couple numbers if that's what you want. So anyway, I hope you enjoy it. I hope you like this module. It's in GitHub. I'm going to actually release version 0.2, which has this API change that I just made, and comment in the video if you think that this was useful for you. See you next time, and I will continue building Python cards. Hopefully in a couple of weeks we will have a live deck and you can start reviewing your cards. See you next time.